Okay, we have written another integral from the Florida integration bee 2016, number 20. We have the integral of sine x plus tan x over 2 cosine x minus 1 dx. Okay, to get started with this, the one problem I have really is just the tan x here. We want things that are going to work well together. Like we like having sine and cosine. If we were going to go with tangent, we'd want like secants, and we could maybe do it that way. But what I want to do is deal with this tangent and kind of just break it up and write it as sine x over cosine x. That way we have everything in terms of just sine and cosine. And then in order to get rid of this cosine in the denominator here, what I can do is if I just multiply through by top and bottom by cosine x, we're multiplying by 1, and this is going to clean up with this. So when I rewrite it, distributing the cosine, the first part here is going to be just sine x times cos x. And then when we multiply the cosine times tangent, the cosine is going to cancel here, and we get plus sine x in the denominator, multiplying this in here. Distributing, we're going to have 2 cosine squared x minus cosine x dx. And then from here we notice we've got sine in common here in the numerator. So what I can do is factor that out and try to set up a u substitution. When I do this, so I can write this as cosine x plus 1, bring a sine x over here to the end, factor that out. And then in the denominator, I think I will factor out a cosine x. So then we're going to have, this is going to become 2 cosine x minus 1. That's kind of silly. I distributed it in and I just factored it out, but whatever. I think you can see where it's going. So what I'm going to do now is let's do a u substitution. We've got cosine everywhere. So if I substitute and I make u equal to cosine x, take a derivative on this, du is just going to be minus sine x dx. Then if I just kind of create, if I multiply in a minus sign right here, then this part is going to be exactly our du. I don't want to change it, so let's multiply by minus in front. Go ahead and substitute this. We'll have our minus. This becomes u plus 1 du all over here u 2u minus 1. And then here, this would be a fine case for partial fractions, but I'm going to kind of try to do it on the fly and avoid it. So what we can do is we have this u 2u minus 1 in the denominator. I kind of create that in the numerator in order to get cancellation. So if I write it like this, u minus 2u minus 1. Well, you notice if you distribute the minus into the second part, you're going to get the plus 1. But then u minus 2u is going to be minus u, and we want this to be a plus u. What I can do is just multiply this by a 3 right here, and then you'll notice if you multiply out this whole numerator, you're going to get back this same u plus 1 here. And so now that we have this broken up this way in the numerator, I can take this and we can split this into 2 integrals, and then we're going to get some cancellation where we can integrate and finish it off. Okay, so now that we have it all broken up, I can cancel u with u here. 2u minus 1, this is going to cancel with 2u minus 1 here. So this is just going to be 1 over u on this one. Now we can just go ahead and integrate. This is going to be, we'll pull a minus 3 out front. Here we're going to have natural log absolute value 2u minus 1, but we need to pull out a 2 as the coefficient on this, so we'll bring it here. And then here for the second one, du over u, that's just going to be natural log absolute value u. And then all we need to do is just back substitute in order to finish it. I think I'll go out of order. I like to have the plus sign in front, so we're going to write this natural log absolute value cosine x minus 3 over 2 natural log absolute value 2 cosine x minus 1, add a plus c, and that's it. Okay, there you go. Good one today from Florida 2016. Thanks everyone for watching. Have a good day.